Olga, and today we're going to be talking about melting, boiling, and evaporation. This is temperature and heat, which is the heating curve we've already taken. During melting, when a solid turns into a liquid, like ice to water, energy is added in the form of heat. This is called latent heat of fusion. So, melting is known as latent heat of fusion, where the temperature stays constant, but we only take the heat to break the intermolecular forces between the particles. So the temperature remains constant, and the added energy is used to break the intermolecular forces holding particles in a fixed structure. So melting is latent heat of fusion. Boiling, when a liquid turns into a gas like water to steam, energy is added as latent heat of vaporization. Here, the temperature also is constant, and the added energy is used to overcome the attractive forces between the liquid molecules to allow them to escape to their gas phase. So we need to know that melting is latent heat of fusion, and boiling is latent heat of vaporization. Here's an example. A block of ice at 0 degrees Celsius is heated until it completely melts and the water is boiled away to form steam at 100 degrees Celsius, or at standard atmospheric pressure. Describe energy changes during melting and boiling. So for melting, heat energy is supplied to the ice at 0 degrees Celsius. Temperature does not increase during melting. It's used to break the intermolecular forces, and this is known as latent heat of fusion. After melting, temperature rises from 0 to 100 degrees Celsius, so there's an increase in temperature, not a phase change. Then comes boiling. At 100 degrees Celsius, water starts to boil. Temperature is taken to break the intermolecular forces between the particles with energy known as latent heat of vaporization. On the other hand, condensation and solidification. Condensation is the process where gas changes to a liquid. As the gas cools down, particles lose energy, move slower and closer together. Attractive forces become stronger, and condensation occurs at the boiling point, but in reverse. Solidification, which is also known as freezing, is the process where liquid turns to solid. As the liquid cools further, particles lose more energy, slow down, go into a fixed orderly arrangement with strong intermolecular forces between the particles, and it occurs at the melting point, but in reverse. Here's an example. A student heats a block of ice at 0 degrees Celsius until it completely melts. The water is then heated until it boils and turns into steam at 100 degrees Celsius. All this happens at standard atmospheric pressure. Describe what happens to energy during melting and boiling. Melting, temperature stays constant at 0. Energy is added as latent heat of fusion to break the intermolecular forces, so particles gain energy and move more freely, changing from fixed to sliding past each other. Boiling, temperature stays constant at 100 degrees Celsius, known as latent heat of vaporization. So the latent heat of vaporization, or this energy, is used to completely overcome the attractive forces between liquid molecules, making particles gain energy to escape the gas and move freely. Remember that during melting and boiling, energy is added, but temperature does not change. It's used to break the intermolecular forces only. Going to evaporation. Evaporation is a process by which particles escape the surface of a liquid and become a gas even below the boiling point. It doesn't have to reach the boiling point. So particles at the surface evaporate, but they have to have enough kinetic energy to overcome the attractive forces from the neighboring particles in the liquid. So the most energetic or the fastest moving particles are the ones that will escape first by evaporation. So the difference between boiling and evaporation is that boiling happens throughout the liquid, evaporation happens at the surface. The temperature for boiling is at the boiling point. Evaporation can happen at any temperature, even below the boiling point. Boiling is fast, evaporation is slow. Boiling causes formation of bubbles, while evaporation doesn't. So the factors affecting the rate of evaporation are 4. Temperature, If the temperature increases, the rate of evaporation will increase because the kinetic energy of particles increase, causing them to escape. Surface area. The larger the surface area, the more the particles are exposed to the air. So this will increase the chances of the number of particles to escape at any moment. So greater surface area leads to more evaporation. Air movement, which is wind or airflow. When particles evaporate, they remain in the air just above the liquid. So if there is wind or airflow, it will cause those evaporated particles to move, removing the water vapor layer, allowing fresh, dry air to contact the surface. So faster air movement increases evaporation. Humidity, which is air saturation. Humidity is the amount of water vapor already present in the air. So if the air is very humid, very little liquid particles can escape from the water up to the air. So higher humidity will actually slow down evaporation. Here's an example. 3 trays A, B, and C contain the same volume of water. Tray A is in direct sunlight, B is in the shade, and C is in a cold room. Rank them in order of decreasing rate of evaporation with reasoning. A will have the high temperature due to sunlight, causing particles to have more kinetic energy. There's a fan which increases air movement, so it removes humid air above the surface. So those are very good factors for increasing evaporation, so tray A will be the fastest. B in the shade has low temperature, so particles have less energy, no wind to remove the vapor from the surface, but the tray is wide and shallow, so large surface area will allow particles to escape, so tray B will be our second option. C, cold environment, low kinetic energy, no wind, small surface area, so all 3 factors reduce the rate, so the evaporation is the slowest in tray C. That's all for today. Please let me know if you have any questions. Wishing you a lovely day.